Okay, for this problem, we need to first realize that there's two parts. One is that we want to be able to withdraw $35,000 from our account each year. So that makes me think about using that payout annuity formula. And we also expect to retire in 25 years, so we're going to also start trying to save in order for that to happen. So if we're going to save every year, then that's thinking about that annuity formula. So the first part, to be able to withdraw $35,000, that is going to our payout annuity. We are going to be taking out $35,000. We're doing this annually, so our K's are ones. Our interest rate, it looks like it's 4% when we start retiring, so then it's going to maintain that as it continues on. So 0.04. And our number of years that we're going to be receiving this payout is 20 years. So we have 1 times 20 here. Again, our interest rate is 0.04. So what I would enter is 35,000 times 1 minus 1 plus 0.04 over 1 to the negative 1 times 20, or negative 20. And then this is all over 0.04 over 1, or you could just put 0.04. So then once we calculate this, then we would be able to find out the amount of money we need in our account in order to make that happen. So this P naught ends up being the goal here. So the question says, how much will you need to deposit each year in order to reach that goal? So I would figure out what this amount of money is. And then over here, I'm basically trying to figure out what that D is going to be. The interest rate's still the same, 0.04. It's still annual rate, so we have a 1 here. This time we're going to expect to retire in about 25 years, it says. So that's how long we're going to be able to be saving. So our number over here for our exponent will be 25 times 1. Because we're going to be only doing this every year, we'll make that deposit. Then again, our interest rate is still 0.04 over 1. So we're going to be able to use that information in order to solve for our D. So I just popped up my decimal scientific calculator, and I want to be able to enter that information. So I have, it will be, let's see, I'm going to scoot this up a little bit. So I'm going to enter the 35,000. I make the division symbol just because I know I'm going to have a double fraction here. 0.04 is on the bottom. But I'm still going to go back to the top. And next to that 35,000, I'm going to enter 1 minus 1 plus 0.04. It's over 1, so I'm just going to leave it like that. Close parenthesis. And I use the exponent button to the negative 20 power. So it looks like my goal is actually 475,661.42. So that's the goal for my annuity, because I'm going to be saving an annuity in order for it to pay out the desired amount of money. So then if I come over here and let's see, what am I going to have? 475,661.42 is now equal to, we'll have D, which is the thing we want to find. My font just got really big there. And we'll have 1 plus 0.04 to the 25 minus 1, close that parenthesis, all over 0.04. So then the next goal would be to solve for that D. A couple different ways to do it. Basically, I see this entire thing sitting right next to D, so I'm going to divide by it. So I'll divide by that chunk. And so then that tells me that my D will be equal to $475,661.42 divided by 1 plus 0.04 to the 25 minus 1 all over 0.04. And so then if I could enter that into my calculator, so I enter that into my calculator. So then entering it into the calculator, again, using my fraction button to put the fraction in the denominator there, it looks like my total is going to be that $11,421. So this is saying that if I deposit $11,421.56 every year into that annuity, that's earning that 4%. If I do that every year for 25 years, then I'll be able to, when I retire, be able to take out $35,000 a year for the next 20 years. So, hope that helps.